Okay, welcome everyone again. So today we're looking at Microsoft database or database in general to begin, and then specifically at Microsoft database. All right. At the end of this lesson, you should be able to cover the following objectives: find a database, give example of a database, identify and create tables, identify and create fields, identify and use appropriate data types when creating fields. Use the terms record, tuple, and row interchangeably. Use the terms attribute, field interchangeably. And create and discuss the usefulness of queries. Alright, so let's move ahead. The key terms, some of the key terms that we'll be looking at today. So at the end of this, you're supposed to be very familiar with these terms: database, table, record, tuple, row, attribute, field, data types, queries. Right, so you're supposed to be familiar with these terms. Anywhere I use these terms throughout the video or in any other video or exam purposes, you should be able to identify what they're talking about. Alright. Alright, so let's begin. What is a database? A database is an organized collection of related data. A database supports storage and manipulation of data. Databases make data management very easy. Some example of a database you may encounter in your daily life are the contacts in your cell phones, the name and attendance in a register, a TV guide, an airline reservation system, motor vehicle registration records, papers in a filing cabinet, or files on your computer system. So once they are files and they are organized, once they are related files and they are organized in some sort of meaningful way, it can be referred to as a database. Alright, so a database can be manual in terms of document files, papers in a filing cabinet, or it can be computerized or electrical, as in the contacts in your cell phone or files that you have on your computer system. So as I said, a cell phone contact directory uses a database to store data of people, phone numbers, and other contact details. Your electricity service provider uses a database to manage bills, client-related issues, and handle false data. So for example, JPS has a large database, and within that database it stores the address for its clients, the names for the clients, the payment history for the clients, the electricity usage for their clients. So they store a various amount of data on each client that they have. All right. We can also look at Facebook as a one as well, because Facebook needs to store and manipulate and represent data related to its members, their friends, member activities, messages, advertisement, and all of this information is stored by Facebook. We can provide a countless number of examples for the usage of database. Okay, now, so within a database, within a large database, we can break it down and we can have tables. So we can have one database, and within the one database, we have many tables, right? A table is a collection of data elements organized in terms of rows and columns. Tables are similar to a worksheet in a spreadsheet application. The rows run horizontally and represent each record. Horizontal meaning going across, right? And the columns run vertically and represent a specific fields. Vertically mean top to bottom. The rows and columns intersect, forming a grid. The intersection of the rows and columns defines each cell in the database. So here we go. So what now is a record? As I said before, a single entry in a table is called a record, or a tuple, or a row. A tuple in a table represents a set of related data. For example, the customer table below has 4 records, right? And let me just bring that up closer so that you can see it. We have 4 records. So we have 1 record here, number 2, number 3, number 4. And we know that is a record because it's going across like that, right? So everything in this row going across is part of 1 record. So there's 1 record here for customer ID 1, for Homer Simpson, and the date created. So all of this information going across is 1 record. All of the information going across here for Peter Griffin is 1 record. So he's customer ID 2, Peter Griffin, and the created date. So if you look across, going across, here we have 4 records going across. Good? Take a moment, pause, and look at that. Now we look at a field or an attribute. A table consists of several records rows. Each record can be broken down into several smaller parts known as attributes or fields. The customer table below consists of 4 attributes: customer ID, first name, last name, and data created. Data created, right? So here we have the fields going down. So this represents one field name. First name is one field name, last name is one field name, and date created is one field name, right? So under customer ID field name, everything going down here is a field under the field name. So that is one field, this is one field. As the arrows indicate, this is one field. This is one field, as the arrow indicates. Alright? So we have records that go across, records, and we have fields that go down. So if I say identify the second field in this table, this will be the second field. If I say identify the 4th record in this table, this would be the 4th record in the table. Alright? So please understand that. Records go across, fields go down. And you will get more examples of this as we go forward. Now, each field, alright, what is a data type? A data type will determine the type of data that the field will be able to hold. This must be defined before entering data. So before we start entering any data into our tables, we get opportunity to define our fields in the data type section. Alright, so here we just have a little breakdown of some of the data types. We have short text, long text, number, large number, date, currency, auto number, and yes, no. And depending on the type of data that you're entering in that field, you have to define the data type. So for example, if it's a short text will hold alphanumeric data. Alphanumeric means letters and numbers, symbols, things like that. So example of what you would store using a short text can be a name, a title, address, any short data, and we see that this will store up to 255 characters. That is individual letters, numbers, or symbols, right? So if you're storing an address, this field type would be appropriate. If you're storing anything else over 255 characters, such as a paragraph or an entire sentence, a long sentence, then you would use a long text, right? So long text is used for large amounts of alphanumeric data, sentences, and paragraphs, up to 64,000 characters. Right? For our purposes for CXC, we may never encounter a situation where we're using a long text, because for SBAs and class assignments and for CXC, most of what we're entering was going to be short text. All right. Next, we have numbers. So numbers naturally represents numeric data, like 1, 2, 3, 4, 5, 6, 7, 8, going up to millions, right? And then you can have, so this will represent up to 16 bytes. And then we have large numbers, which can represent far more by larger numbers, specifically for large calculations. Again, we won't encounter any of these for our sessions, right? We have date and time, which use anywhere appropriate for date and time, such as date of birth, anywhere where it requires a date for a specific purpose, when something was created, when an event ended, a reservation date, anything like that that requires a date or time, they use the date and time data type. Currency, as the name suggests, any monetary value, you use a currency, and that will automatically put the dollar sign on it. There's an auto number, meaning if we create a table, and as we are entering data going down, the auto number feature will automatically increase each time. So the first one will be 1, the second one will be 2, 3, 4. So it will automatically do that for you. In some cases that might be useful. In other cases you might want to specify your own numbers. For example, if you're using a system that requires an ID number, you want to specify your own numbers. You might not want the computer to be automatically creating ID numbers for you. Alright? And then yes, no is a feature where you can have any situation where you have true or false, yes or no. So for example, if somebody is saying uh does the patient have a fever? Yes, no. You can use this feature, so it will give you like a checkbox where you can tick it for a yes or no, tick it for no. Alright. So again, based on the data that you're entering, you must create the right type of data type. Right, and this will determine how you get to enter your data and how you manage and manipulate the data going forward. Alright. Relationships between tables. So in situations where we have multiple tables. So for example, look at this case where we have table 1, we have table 2, and we have table 3. Right? In many cases, we try to break down data. We don't want the tables to get very large. So for instance, if you are in a situation where you are a patient, or for example, if you're a visitor to a hotel, the hotel might break down the information that they store for you. So for example, in table 1, they might store your first name, last name, your gender, anything to do with your personal information, your address, things like that, they might store in one table. In the second table, they might store your reservation details, such as the room that you're staying in, the duration that you're staying for, what type of room you're staying in, information like that. And then for table 3, they might store your financial data. For example, how much money you're supposed to pay, how much discount you received, how much money you actually pay, if you actually owe any data. Right? So table 1 might store personal information, table 2 store some reservation information. I'm just giving you an example. And table 3 might store some financial information. It is all related now because the three tables are still talking about the same person. It's just that the data is broken up sorry, to make it easier. So you see in this case, the person had a visitor ID for this field name. And you see here, so again, there's another visitor ID. And for table 3 again, there's another visitor ID. So what the computer is going to do, it is going to compare look for the visitor ID in all 3 tables, and it treats that as one person. So here we have, let's say we are looking at visitor ID A1200, and that might have some financial information. If you look for visitor ID A1200 here, it's showing you the name of the person and the address. And visitor A1200 here is showing you the amount of nights that they stayed and the duration for the stay. So even though it's broken up into 3 different tables, it's still referring to the same person, and it's able to connect all 3 tables using the visitor ID. right? So this is a very important feature. So what it has done is you will create a relationship between the three tables using the visitor ID, right? Bear in mind, if the visitor ID wasn't present, if there were no visitor IDs, there will be nothing to link the three tables with, right? So you can't link a cost with a first name and number of nights. You can't link it like that. You have to link the same type of data. So in this case, we were linking visitor ID with visitor ID with visitor ID. And you might be wondering, why we couldn't link a name. So for example, if you had a name in table 1, name in table 2, and name in table 3, why we couldn't do that? Simple. We can't link data that can be duplicated, right? So what I mean by that is that you can have more than one person by the name of Kevin. So if in table 1 you had 3 persons named Kevin, it's going to be difficult to link it to table 2 with 3 persons named Kevin, because you're not going to know which record belongs to which one of the Kevins. Even if you name it Kevin Brown, you might have multiple persons with Kevin Brown. Alright? So you don't want to set up a database that can get confusing like that. Alright? If for example if it's a hotel will have thousands of visitors, possibly even at a given time. And naturally, most at some point, some of those persons are going to have the same names, right? So you can't link the table using data that can be duplicated, right? So we have to use what is called a unique field. Unique meaning no other person will have that exact data, right? So we call this a unique field. So more than likely, a unique field is usually an ID. When you have an ID, no two persons have the same ID number, right? In different cases, you can use different things for your unique field. So, for example, you could use a passport number for a unique field, because no two persons will have the same passport number. In Jamaica, for most of our financial transactions, if you go to the bank or the tax office or anywhere, they ask for a TRN number, right? The TRN number is a unique field because no two persons have the same TRN number, right? So it make it easy to manage like that. If you go to a hotel, they might give you a visitor ID number. No two persons would have that, right? So that's the importance of it. So you can only link tables using a unique field. So for example, for your SB that you're going to be creating, your table should have some sort of ID number, and then naturally you'll use the ID numbers to link the fields. Now let me show you what might happen. You see, if you don't link the fields, you can create the tables now, but if you don't link the fields, the first record, hoping you're seeing what I'm doing here, this record is going to try to link to that record, that record, that record, that record, that record going down. The first one is going to try to link to all of them in the next table. And then the second record is going to try the same thing to link to all of them in the next table. And then the third one is going to try to link to all, going all the way down. So even the last one here so is going to be trying to link to all the records in the next table. And then the next table, table 2, will try to do the same thing to table 3. And as you can see, this is going to get very confusing, because now you're going, in this case, I have 10 persons in each table here. So 10, right? 10 persons in each table here. So, right? If I use a unique field, all 10 persons will be linked. So I will only end up with 10 sets of information. If there's no unique field, by the time I go cross with this 10 here so going to try to link with this 10 over here. So I'm going to end up with 100 connections. And then this 100 over here, so I'm going to try to link with this 10 over here. So I'm going to end up with 1,000 connections. You get what I'm saying? So I'm going to end up with 1,000 connections or 1,000 sets of data, where I'm supposed to only have 10 sets of data. So you can see the significant difference with that. So if you're managing a database in a hotel, if you don't set up a database properly, your database is going to show you that possibly you have 1,000 people in your hotel when you only have 10 people in your hotel. You understand? So it's important to set it up properly. So we set up a relationship using unique fields, such as a visitor ID with a visitor ID with a visitor ID, right? All of these visitor IDs must be of the same data type. meaning you can't have one visitor ID created as text and another one created as number or something like that. It's not going to connect. Additionally, all the data in all your visitor IDs must be the same set of data. Meaning, if you have a1200 here, so you're supposed to have a A1200 here in table 2 and a A1200 here in table 3. If you have different types or different pieces of data, it's not going to connect, because what is in table 1 will be looking for the same ID in table 2, will be looking for the same ID in table 3. Alright, so once you can get that connection done when you're creating a table, then you'll be fine. And when we run through the example, you see that it's very simple to do. I just had to explain it properly so you understand the significance of it. All right, so let's move on. So let's look at some examples now. So here we have a basic contacts database, such as the contacts that could possibly be in your telephone, in your phone, the contacts in your phone. So your contacts might be asking for a first name, a last name, a home contact, date of birth, TRN, address, email address, but probably not in your phone, but some sort of customer base contacts, right? So in this case, there's one table, and it's possible in a database to have one single table. Nothing is wrong with this, right? So in this case, the first name, and you can see the data type for the first name, the last name, and the data type for the last name. We have a date of birth, and we'll make sure that we declare that as date. TRN, we declare that as a number because it's all numbers in a TRN. Alright, amount paid will be currency, so you get the picture, right? How you have your, so all of these here, so will be your field names, and all of these here, so will be your data type, meaning the type of data that the field is storing. Alright, let's look at another database. Here we have the My School database. The My School is similar to the one that you are familiar with at school, right? That store your reports. So in this case, we're looking at the data, the design view first, right? The design view is going to show you the properties of the table, just like what we were looking at before, where you have the field names in one column and the data type in one column. So this shows you the properties for the database. So here we see we have the ID for the personal information table. For the grades table, we have to have an ID as well to create that relationship. For the accounts table, we have to have that ID again to create the relationship. So for the personal table, personal information table, it's going to store your ID, first name, last name, date of birth, address, email, parent, contact. That is your personal information. Then you might have your grades table that show all of the information regarding to your grades. Math grade, English grade, IT grade, Spanish, averages, things like this. And then your accounts table now that stores your school fee, rental book fee, if you have any medical fee, if you have any exam fees, things like that. This, right? And you might wonder why we need to break up the data. Why not just put everything in one large one large table and manage it like that? Now, bear in mind, within a database, for example, a large organization, just like into high school, different persons might require different access to information, and not everybody will be required. Not everybody will be given the same access to all the information. So, for example, teachers teachers will be given access to your grades table and your personal information table, but teachers might not see how much money you owe the school. They wouldn't see that information because that is none of their business. They're only concerned with your grades and your name and your contact information. On the other hand, the accounts department would need to see your personal information and your accounts information, but the accounts department is not concerned with your grades. They're not business if you're passing or failing. They just want to know that you pay what you're supposed to pay. You understand? So this is just a means, a way of controlling who has access to your information. And then you know, as the administrator, the database administrator or the database manager, you will have access to all information. So you will have access to all three, so that you can manipulate and do that what that you need to do. Alright, so this is the design view, which shows the properties. Once you have created the tables in the design view, you would then sorry, you would then go to the data view. So the data view now will show you all of the information that you should have in your database. The data view is going to start off blank, so you would only see the headings. So for example, the personal information table, you would only see the headings when you start off with a blank table for the personal information. Then you will start to put in the information. So you put in the ID number, the first name, last name for all of these individuals. You put in a second ID number and you make sure that it's different from the first one. And then you put in the information for that person and you go on. You can go to the grades table and you can look for the 1025. So the person with ID number 1025 is Kevin Brown, and it's the same person down here. So, but as we say, we'll put them in three different tables. Alright, so every person that you create in one table with one ID number, you have to make sure that the same ID number will exist in the next table and the same ID number will exist in the next table. Right, this way we ensure that we are keeping proper records for each person. So in a situation where you don't have a name for the ID number for one person in one table, it means that somewhere along the line this data is lost, and it means that you need to either rectify this or, well, you just need to rectify it. Alright? So I'm hoping that you're understanding this so far. So this is your data view. Your data view shows the full content of the tables. The design view shows the full content of the properties for the tables. Alright, properties for the tables meaning the data type and the data name. The data view shows all the contents of the database, and the tables meaning your whatever you put into the database. Alright. Next now we can create what are called queries. So let's look at this. The data that is stored in a database is organized. Therefore, it makes it easy to search, retrieve, and manipulate data that is stored. A query is a function that will search a database for a specific set of data. A query can search a single table or multiple tables, then compile this result into one query file. For example, a database that stores all the information for a student in a school. A query could be created to search the database to only retrieve the subjects that the data is passing with 50% or more, or greater than 50%. Meaning that for the database that we have for you at school, we can look through the tables and create a query to identify all the persons that are passing maths with 50%, and that will search through the entire database, the entire tables, and it will identify only the persons that are getting greater than 50% in maths or whichever subject that we specified. All right. Similarly, we can join it with other tables. So we can do a query that searches across multiple tables. So for example, I can do a query that says I want all of the persons who pass maths or get greater than 50% in maths, and those who owe no exam fees. So that is searching two different tables, and then to tell me everybody that pass maths and don't have any exam fees. Alright? Let's look at example number 2. Coach Jamaica has a database that it uses to store all transactions for all customers. The management at any time can run a query to show all persons that have outstanding balances. This query can then be printed and sent to the collector. So the courts can, at the end of the month, they can bring up on the screen, run a query to identify who and who have outstanding balance. Or specifically, let's say they want to know who and who don't pay the money for the past 3 months. and I can do a query that will only show the persons that haven't paid in the past 3 months, and then the names of those persons can be sent to a collector or bailiff or whatever the case is. All right, let's look at a little example here. This is my query that I want to create. So look at this. A query with all students and their grades and exam fees. So here I have 3 tables. I have this information table, this grades table, and this accounts table right here. So the query asks for all students and their grades and their exam fees. So they want all students. So this is the information for all students, the ID, first name, and last name. So you want those 3 fields only from the personal information table. Then it wants all grades. So for the grades, it wants these 4 fields from the grades table, and then it says and the exam fee. So it only wants the exam fee from the accounts table. So when I run this query, it's going to take the 3 fields from this table, the 4 fields from this table, and the 1 field from this table, and it compiles it all into one query, which I have here. So you see the query down here, so now consists of all the fields that I took from the other tables, and put it in one table. So I can see all the persons, their grades, and their exam fees all at one time. You get that? So I created a query here that searched through just based on what I specified for all students and their grades and the exam fee, and I got it from 3 different tables and put it into one table. So I could now print this as my recommendation sheet or my exam sheet or whatever the case is. All right, let's look at another example here. So here we have, this is the question, a query to show all persons that got over 50% in maths and English, right? So all persons, their names are in the personal information table, and their grades are in the grades table, right? So it's 2 different tables. So they want all persons, meaning they want all their first name and their last name, and they want their information for maths and English, but it's not just for maths and English. They want all the persons that got over 50, meaning that under the field for maths, you need to specify greater than 50. Under the field for English, you would specify greater than 50. So the query would then run through all. So if the school had 10,000 students, the computer would run through all 10,000 files and identify only the persons that have over 50 in math and English. So in this case, it's only one person had greater than 50 in math and English, right? Which is Stacy Black. Because they had 17 maths and 59 in English. That's why you only see one person come up down here, so with for Stacy Black, 17 maths, 59 in English. Alright, so this is how this should work. So you just specify under the field name exactly what you want from it. So if you did put 80 here, so it would only show those who got greater than 80. Alright, now bear in mind the only way you can use this greater than 50 and greater than 50 here, so is if you had specified maths as a number, as a data type, and the English as a number for the data type. A lot of the mistake that students make sometimes is they just leave everything as text, right, in the data type. So when they come and they try to do something like this, it don't work. Because they have maths as text, even though it's storing number, and English as text, even though it's storing number. So if you say greater than 50, you can't have greater than 50 for a text. You can only have greater than 50 for a number. So that is part of why, and again, it's important that you store your data types correctly. Sorry, so that when you're ready to do your queries and other things like this, you won't have that problem. Alright, so that's it for this section. I hope you understood that. You can go back and review it if you want. The next section is going to look specifically at example of how to create the database, how to create the tables, insert the tables, and all this. Alright, thank you for watching.